Okay, so are you ready? Let's do it. As usual, as I mentioned just now, I might not be able to respond to your live chat immediately. So after the session, I'll be replying all of you later. And if any questions that you are not very sure, so you can try to ask me later on. Okay. So without hesitation, let's begin our uh, lesson, shall we? Okay, so yesterday we have already finished chapter 1, so today we are going to continue with a brand new chapter, which is chapter 2 about hydrocarbon. So I hope that you all already have the questions with you from my modules that you already purchased through Shopee. If you still haven't have it, you can always purchase through Shopee apps, okay? Okay, so let's have a look at the objective questions that I've already prepared for you. Let's start from question number 1. So ethene react with bromine to form two products, CH2Br, CH2Br, and CH2Br, CH2OH. Which of the statement about the product could be correct? Now, this one, you have to know by yourself that this is the reaction of alkene with bromine aqueous solution. Bromine aqueous solution. So when it is a reaction between bromine and aqueous solution, so you have to know what are the products that you expected to get at the end of the day. Okay, so A. Both products are contained by electrophilic substitution. Now, it is not electrophilic substitution. Instead, it is electrophilic addition. Okay, electrophilic addition. Okay, it is not electrophilic substitution. It is electrophilic addition. Okay. And then both products are obtained by the reaction of nucleophilic additions, as I explained. So both products can hydrolyze to form the same glycol in here. What does it mean in here is they can use the glycol in here is the terms glycol in here is actually refer to CH2OH, CH2OH. Okay, so now you can form the same product. Okay, means that after this one you react with NaOH under reflux. Okay, and this one you react with NaOH under reflux, both of them form the same product as glycol. So that is what it means in here. Okay, and then finally the D says that both product can form hydrogen bond with water, not the first one but the second one, yes. Okay, so that is what it means by number C in here. Okay, so the answer in number 1 is C. Okay, number 2, the following mechanism shows the reaction between methane and bromine in the presence of light. So here are the step 1, step 2, and step 3. Okay, so which of the following statement about the reaction could be correct? Number 1, the above reaction carried out in a dark room. So this one cannot occur in a dark room because you need light. You need actually UV lah. You need actually UV to initiate the reaction. However, once you already have a methyl radical, the purpose of the UV is to actually produce radical. So in another word, once you already have a methyl radical inside your reaction, even if it is under a dark condition, the reaction can still go on because the purpose of having UV is to produce the radical. So since you already have the radical, so even if it is a dark condition, the reaction can still occur. Okay, and the only product form is CH3Br, which is also not correct because you can form multiple chlorine product. You can also form CH2Br2. You can also form CHBr3 and etc. Okay, there are many possibilities that you can form from the side product in here. And the above reactions stop at step 3. Step 1 is initiation. Step 2 is propagation. Step 3 is also propagation. And then we have another step 4, which is termination. Where in termination, you'll find one of the example of termination is bromine radical. Okay, plus a CH3 radical to form CH3Br. Okay, so that is for the reactions in here. Okay, so the best answer in here is boy B. Okay, so that is for question number 2. So immediately we move to question number 3. Hydrocarbon Z exists as a liquid at room temperature. So the keyword in here is liquid up. And for hydrocarbon, if you want to exist as liquid, for your information, C1 to C4 is usually gas. Usually C5 to C10 okay, is liquid. Okay, and then C11 and above are usually solid. So this is a rough guidance of how many carbons that you should have in order to form what state of matter. Okay, and the next keyword is decolorized bromine water in the presence of a little finely divided ion. Okay, so this one that is trying to tell you that the reaction contains a benzene. Okay, so what is the possible answer? As I told you, this is a gas. Okay, this is a gas, and this is a liquid, and this is a liquid. Okay, and then decolorized bromine by a little fine iron, as I told you, is the property of a benzene. Okay, so the answer will be C. Okay. So that is for number 3. And then number 4, hydrocarbon X contain 85.7% of carbon and 40.3% of hydrogen by mass. X react with hydrogen in the presence of a nickel. So after you calculate the empirical formula for it, so the empirical formula for it is CH2. Okay, when 85.7 and 14.3 is the empirical formula for CH2. Okay, and therefore also can react with nitrogen. So automatically alkane is out from our choice. Okay, so the answer may be B, B or C. Okay, now D is also out from our choice because C in here empirical formula is C3H5. Okay, so D is already out. And the information that says that X react with hydrogen in the presence of a nickel catalyst is trying to show you that there must be a C double bond C inside them to undergoes hydrogenation. So the best answer in here will be B. Okay, number 5. Which of the following compound could be the major product when cyclohexane react with bromine water? So when react with bromine water, what are the products in here? It can be either OHBr and also BrBr. Okay, but C and D are both wrong because inside here it shouldn't be the unsaturated hydrocarbon. It should be the saturated hydrocarbons already. And in this case, even though the question said they want major product, but in here you must know lah. This is the only major product. Okay, and this is the minor product. But since in here there is no other answer that best fits towards the description of the product form, so the best answer in here is B. Okay, okay, so that is for question number 5. Then we have go to question number 6. When two organic X and Y form two different homologous series, burn separately to an excess oxygen in ordinary pressure, the volume of carbon dioxide is the same with the water vapor. X and Y could be what? Okay, so in here, in another word, if you want the same volume of the carbon dioxide and vapor, so it must be NCNH2N. Okay, you form when you add with oxygen, I mean. Okay, so you form a NCO2 plus 2N over NH2O. Sorry, 2NH2O. Okay, so therefore, it must be empirical formula of CH2 lah. Okay, empirical formula of CH2. So in here, the possible way, alkane and alkene are two different isomer already, so they are different already, so cannot be. Alkane and aldehydes also have different empirical formula. Aldehyde and ketone also have different empirical formula, and the best empirical formula in here is cycloalkane and also alkene. Okay, so that is why they must have the same number of moles. Actually, in the question, if they said aldehyde and ketone, the answer then may be aldehyde and ketone. Okay, so that is for number 6. Okay, number 7. The chlorination of methane involved in a few steps. Some of them are given below, so these are the steps of this one. So for your information, this is the initiation. Okay, The second one, this one is propagation. So it's the third one is a propagation step. The fourth and the fifth are both termination step. Okay. So which of the following about the steps is incorrect? So please be careful. We're looking for incorrect. Okay. So chlorine free radicals are formed by homolytic fission, which is actually correct because it ends up forming a radical. So therefore homolytic fission, correct. Step 3 and 4, as we mentioned just now, are terminating step, which is correct. Okay, so ethane is formed as a byproduct in this reaction. So in here you can see how ethane is formed, which is also correct. And the reaction stops when all hydrogen atoms in the methane molecule are substituted by the chlorine molecule. Now the reaction does not stop. The reaction still keep on going in here. So that is why it is possible to form other sides product other than this. Okay, so the best answer in here is donkey D. Okay, so that is for question number 7. Okay, as for question number 8, oxidation of the alkene give diol. Further oxidation of diol give diketone. Which of the following could be X? Okay, so in another words, in your alkene in here, you must have alkene C double bond C. It first oxidation. Okay, I use bracket O even though it's not really appropriate. It says that it must contain first form a diol. Okay. And then further oxidation of the diol will give a diketone. Okay, will give a diketone. Okay, now in here, when they said that it must be a diketone, that means here and here must have another 2C, isn't it? Okay, so therefore here and here must be also another 2C. Okay, and in here you must know by yourself, this is in order to form a ketone, okay, you must be oxidized from a secondary alcohol. Okay, so to form a secondary alcohol, it must come from a secondary alkene. Okay, so both of them must be from a secondary alkene. So which one are secondary alkene? Let's identify one by one. So this one is a tertiary and tertiary alkene, whereas this one is secondary and tertiary, while this one is a secondary and primary, while this one is a secondary and secondary. Okay, so the answer is very clear that the answer is D. So that is how you are going to identify which one will oxidize to give a diketone. Number 9, an energy level diagram for a single step reaction is shown below. So this is a single step. To which of the following step is a reaction of methane with chlorine in the presence of light does this diagram apply? So if you have reactant low, product high, so this is an endothermic process. Okay, this is an endothermic process. So what are the steps inside the mechanism that is endothermic? Usually endothermics absorb energy to break the bond. And among them, which one among the ABCDs are where the mechanisms are breaking the bond? So in here, A is not correct because it's breaking and forming. So this is not the case. Then this one, termination, is formation of bond. So this is also not correct. Whereas this one is initiation. So initiation, it forms homolytic fission. Homolytic fission means that it breaks the bond. And finally, this one is positive, negative. This one, even though it is also bond breaking, this is a heterolytic fission. But look back at our question in here. Our question says, is the reaction between methane and chlorine in the presence of light? So usually this is a free radical substitution reaction. So in a free radical, so even though when the bond is formed, even though the bond is break, it must be a homolytic breaking. Therefore, the best answer in here is C. Okay. Okay, so that is for question number 9. As for question number 10, 1,2-dichromopropane DBCP has been used in controlled earthworm in agriculture land. Which of the following would best synthesize this compound? So you have to first identify what is the structure of the 1,2-dibromo-3-chloropropane. So you have CH2Br, CH2Br, CH2Cl. Okay, so what could be the possible way to synthesize this? So let's together study one by one. Okay, so since this is an alkane, so alkane, because it is a random reaction, so it might not necessarily give the reaction product, because in this case, when it is a free radical, any product is possible. So A is not the best answer. Okay. Whereas this one, what is the product given in here? So we are following the according to the Markov-Nikov rule. So the outcome of this product will form in here is CH3Cl, CH3, CHCl, then CHBr2. Okay, whereas this one is also a free radical reaction, so you might not get the best result, and so therefore the best answer in here is D. When here after you substitute the BrBr, so add the BrBr, so you form the dibromo in here. Okay, so that is for the question number 10. Question number 11. Which of the following about the two alkenes are incorrect? We are looking for incorrect. So what is the difference between boot 1 in and boot 2 in? Okay, so number 1. Both exist cis trans. So in here, only boot 2 in exists cis trans, but boot 1 in does not. Both may be polymerized. Both can be polymerized. Okay, both can be polymerized. Both react with bromine to give 1,4-dibromobutane, which is not correct. In the first one, what is the expected product? So you form CH3, CH2, CHBr, and CH2Br. So CH3, CHBr, CHBr, CH2. Okay, this is the expected product. Okay, and finally both react with hydrogen to form bromine, which is correct. Okay, so both of them at the end of the day will form the same butane. Okay, so now we are looking for incorrect. Okay, we are looking for incorrect. So number 1 is incorrect. Number 3 is also incorrect. So the best answer in here is 1 and 3. Incorrect. B. Okay, so that is how you answer for question number 11. Okay, immediately we goes to question number 12. Which of the following hydrocarbon could form a monochloro-substituted derivative showing both optical cis and trans? So we are trying to see that how hydrocarbon could form a monochloro-substitution derivative that shows both cis and trans in here is where when you react with the HCl, for example. Okay, so in order to react with HCl, if you want to substitute to form when you want to substitute one of the hydrogen with the chlorine in here, so you might want to form both optical active and also this geometrical isomerism. So if you can you imagine that if you were to substitute anywhere from here, let's say you substitute chlorine, okay, you substitute chlorine in here, okay. So now if you substitute any of the chlorine here, this can give geometrical but cannot give optical, isn't it? Okay, you can give geometrical but cannot give optical, so we want both geometrical and optical. Okay, so geometrical can, optical cannot. Okay, as for the C, if you look carefully, if you substitute any of the chlorine in here, okay, chlorine in here, yes, you can get geometrical, but you also cannot get optical. Okay. As for the third one is B. B is generally almost the same with C here. Okay, where let's say that if you substitute this one, if you look carefully, even if you substituted any of the chlorine, it cannot give geometrical. It also cannot give optical. Okay. And finally, for D, if you substitute any of the chlorine in the parts here, okay. Now, if you substitute one of the hydrogen with chlorine, okay, you can have geometrical, Okay, and this one will become the chiral carbon atom, which is optical. Okay, so the best answer in here is donkey D. Okay, number 13. Alkene can obtain from the following reactions. You have C11H24 indicane to give C9H20 and C2H4. So this is actually what type of reaction? This is actually a bond breaking, which is a cleavage. Cleavage is what we so call cracking process. Okay, the cracking process is a cleavage process. The terms cleavage means breaking the CC bond. Okay, so therefore the best answer here is donkey. Number 14. Which of the following statement will explain why nickel is used as a catalyst in the hydrogenation of ethene at 200 degrees Celsius according to the equation? So this is the general equation for this one. So what is actually the purpose of using nickel? This one, if you remember for semester 2 that we learned last time, we have a homogeneous catalyst and heterogeneous catalyst. So this is a type of heterogeneous catalyst. When here, nickel making use of its empty d orbital, it forms a temporary bond. We call it as a chemisorption. Okay, we call it as a chemisorption to form a temporary bond that actually weaken the hydrogen-hydrogen bond, because hydrogen-hydrogen bond is very strong. Okay, so that's why you need active site to weaken the bond, hence makes the hydrogen easily breaking to form the alkane involved. Okay, so that is why in here the best answer for this question is boy B. We go to number 15. Trichloroethane CHCl2 is widely used as a dry cleaning agent. Which of the following does trichloroethane react to give a chiral product? Okay, so what is the answer for each of the product in here? So we are going to discuss one by one. What is the expected product when each of these react with the substance involved? So you have CH2, CHBl, so you have Br and Br. So do you see that is there any chiral carbon atom? So as long as you have two, definitely you will not give a chiral carbon atom, isn't it? Okay, so this one, however, this one can give a chiral carbon atom. This one can. So this is the chiral carbon atom. Okay, okay. If hydrogen, what is the final product? So you have CH2Cl, CHCl2. So this one, because of the 2 and 2, so this cannot have a chiral carbon product. And HCl, according to the Markov-Nikov rule, so you have CH2Cl and CCl3. So both does not exhibit this one. And the chlorine, when you react with sodium hydroxide, so what is the expected product when you react with sodium hydroxide? So the expected product in here, because chlorine can undergo hydrolysis, so you form CHOH, the double bond. The double bond still remain, okay? Then you form C double bond H, which is actually quite impossible to take place, because carbon cannot have 5 bonds, isn't it? So therefore this reaction cannot take place, okay? So therefore D is also not true, okay? So the best answer in here is A, okay? Okay, so this is number 15. Number 16. A mixture of ethane gas and chlorine gas were exposed to sunlight. Which of the following molecule may not be the product of the reactions? So you have to understand the series of steps of reactions that is formed from here. When chlorine react with CH3Cl, it can form many products starting from CH3Cl2, CH3CH2Cl, HCl as a side product. Okay, so what could not be the final product in here? So the final product in here is C, because C has only one carbon. So in the homolytic fission, you cannot break carbon-carbon bond. Cannot. Okay. Okay, so this is for number 16. And then number 17, ethane has low reactivity due to the following reason except. So ethane is a low reactivity since it is a non-polar molecule with no C double bond C between carbon, hence are passive towards the reaction. So in here, it is because of non-polar, correct? And it is because it is a saturated product, correct? It does not have a pi electron, and the statement that says that it does not have a charge center, does not have a charge. I think the answer is donkey D. Sorry, the answer is donkey, not boy. The answer is donkey. Sorry for that. It does have a charge center. It does have a charge center. What does it mean that it does? It does have a charge center. It's because if you look carefully in between the, if you look carefully in the structure of the this one, actually a carbon has a charge center because don't forget this what uh, H are all partial positive, okay, carbon are partial negative, but because of the cancelling off between this one, okay, so it will make the overall dipole is approximately equals to 0 lah. Okay, however, uh, in here it does have a charge center. It does have a charge center. It is partial negative charge for here, but because of the cancellation between the dipole magnitude, the vector in between the alkane, so they cancel off each other, hence this makes this molecule approximately equals to 0. Okay, so that is why it is a non-polar molecule. So the statement saying that it does not have a charge center is wrong. Okay, okay, so the best answer in here is donkey D. Okay, number 18. Which of the following pair is correct regarding the type of bond and mechanism involving alkene? So in alkene, you must have a C double bond C, and most of the alkene take electrophilic addition reaction. So the best answer in here is donkey D. Okay. Number 19. Which of the following reaction involve electrophilic reagent? So if you look carefully here, you are looking for electrophile. So this one is electrophile, yes. Okay, you add into a C double one C electrophilic addition reaction. So this is a type of electrophilic addition reaction. Whereas this one, chlorine react this one, this is a free radical substitution reaction. Okay, as for this one, this is a nucleophilic. This is a nucleophilic. So this is a nucleophilic substitution. Okay, specifically SM2. Okay, okay, and whereas this one is oxidation. So it does not behave like an electrophile or anything. So the best answer in here is A. Okay. So this is for the question number 19. Then we go for question number 20. Catalytic cracking is an important process in the petroleum industry. Which of the following is not true regarding to cracking? So a cracking process is actually used to shorten the carbon-carbon bond that is that is usually not frequently applied in our daily life. Okay, for example, C30, C14, we don't tar road every day, isn't it? So that is why catalytic process is developed to to make use those very long carbon, shorten them, and apply them to a more useful industry. Okay, so that is why it is used to produce petrol with a lower octane number. It's true. It is used to produce petrol from kerosene fraction, also true. It is used to produce alkene to become a more useful petrochemical. It's also true. It produces alkane with a more branch. So the best answer in here is A. Okay, to lower octane number because you want catalytic cracking. Okay, catalytic cracking usually will produce a high number of the octane number, high octane number. Sorry. So the best answer in here is A. Okay, so that is for number 20. 21. Ethene react with hydrogen halide HX according to the following reaction. So in this reaction, which one is true? Okay, A. Pi electrons are used to form bond with hydrogen atom from HX. Yes. So the first step of the mechanism is you form a you form a carbocation. So the first step of the mechanism is where the C double bond C will attack the partial positively charged carbons in here. Okay, so C double bond C attack the partial charged carbon so that you form a carbocation. So this is the first step of the reaction. Then only then you attack the negative, okay, to the positive. So you form a CH3CH2X. Okay. So pi electrons are used to form the hydrogen bond is correct. Okay. The intermediate of the reaction is a carbocation, as I mentioned just now. This is the carbocation. Okay, which is correct. The rate of the reaction increased from HCl, HBr to HI, which is also correct because bond length increases. Okay, because bond length increase, bond strength decrease. And in here, the intermediate is the carbocation, so not this. Okay, so that is why our best answer in here is A. Okay, okay, so this is for question 21. For question 22, which of the following is the product obtained when ethene is oxidized at 300 with oxygen at 300 using silver catalyst? Now, this is a very direct question where this is actually a process to form the what we so call as the epoxide. Okay, so the best answer in here is C. Number 23, the reaction below shows the effect on heating with the alkane number under two different conditions. So X in here, when you undergoes oxidation, you form 6CO2 and 7H2O. And then this is actually a cracking process. This oxidation. Okay, so what could possibly X be in here? Now, this is a very tricky question at times because if you analyze wrongly, then it all goes wrong. So in here, from the answer in here, 6C and 7H, you must know by yourself that X has the general formula of C6H14. So anything with not the formula of C6H14 may not be the choice. So hexane, correct. 2-methylpentane, also C6H14, also correct. Okay, 2,2-dimethylbutane is also C6H14, also correct. And then 2,3-dimethylbutane, also C6H14, which is also correct. But does it mean that all 1, 2, 3, 4 are correct? Now the key lies at here. After the cracking process, you form a propane and also a propene. So which one can be the answer for this one? Now, can you imagine what happens when these molecules are broken? So let's start from hexane. So if you break hexane, okay, so let's say this is hexane molecule. So in cracking, at the end of the day, you produce one alkane and one alkene. So you break here. So when you break here, this can form the alkane, and this can form the alkene. Okay, so one is correct. Okay. Okay, as for number 2, what happens when you break 2-methylpentane? So this is the structure of 2-methylpentane. Let's see, CH2, 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 CH2. Okay. Now if you break from here, okay, so here you can also form propane, and here you can form propene. So number 2 is also correct. Now number 3, 2,2-dimethylbutane. When you crack 2,2-dimethylbutane, can you get the desired product? Now remember, only one covalent bond can be broken in here, not two. Now this is what happens when you break 2,2-dimethylbutane. Can you imagine, if you break from here, now if you break from here, you produce 3-methylpropane and ethane, or you break from here, it produces methane and also alkene with 5C, isn't it? So it is impossible for you to break something that becomes 3C and 3C, isn't it? So therefore, number 3 is not our best answer. As for number 4, what happens if you break 2,3-dimethylbutane? So this is how 2,3-dimethylbutane looks like. Okay, when 2,3-dimethylbutane, if you crack here, this one is at least 3C, and this one also at least 3C. So 4 is correct. So the best answer in here is 1, 2, and 4. Okay. Okay, so that is for question number 23. Then we go to the next one, 24. An organic compound contains 59.7% of chlorine by mass is formed when hydrocarbon P reacts completely with chlorine without evolving white film. So this is basically addition reaction, because in addition reaction, usually you don't produce HCl as a side product. So the key in here stating that evolving white film. Okay, sorry, when you say evolving white film, this is actually referring to the formation of the HCl. Okay, so HCl is usually obtained when you undergo a substitution reactions. So which of the following could be structure of P in here? Okay, so to understand this, you must first find out what is the empirical formula for the compound that is formed in here. So after you react with all the chlorine, okay, so you eventually find out that when you react with chlorine, so this is the product, okay, you form CH3, CHCl, CHCl, CH2, CH2, CH3 for number 1. As for number 2, at the end of the day, when you have a triple bond, so you form CCl2, CCl2, okay. As for number 3, when you react with the chlorine, so you substituted chlorine and you add chlorine and chlorine in here, isn't it? Okay, and finally, when you add cyclohexene with the chlorine, so you form this product, isn't it? Okay, from the product of the 4 answer in here, we eventually find out that the percentage of the chlorine for A and D is already wrong. Okay, because it's 42%. So the answer might be B and C. Okay, 2 and 3, sorry, 2 and 3. So therefore, our best answer in here is C. Next is 25. Which of the following reaction occur in a catalytic converter? So in a catalytic converter, you are trying to convert carbon monoxide to become carbon dioxide. Nitrogen dioxide or nitrogen monoxide is reduced to nitrogen and oxygen, while unburned hydrocarbon is converted to become carbon dioxide and water. So which of the following can be occurring inside here? So first is correct because it undergoes oxidation. Number 2 is wrong because you cannot undergo oxidation. Usually it undergoes reduction. Now number 3 is a redox reaction. Number 3 is a redox reaction, where in here, if you notice carefully, nitrogen in here is undergoes reduction, while carbon dioxide in here is undergoes oxidation, where the oxygen to the NO is contributed to the carbon, so hence reduced. So number 3 is correct, and number 4 is oxidation. So the best answer in here is 1, 3, and 4. Then we go to number 26. Gas given off vehicle exhaust after environment and affects the environment and living thing. Which of the following is not the effect of the gases? So in here, which one cannot? Greenhouse usually contribute the gases such as what could be contributed by the exhaust gas? You contributed CO, you contributed CO2, you contributed NO, you contribute NOx, and then you also contributed this one. Okay, so will it produce acid rain? Due to the presence of carbon monoxide and nitrogen, you can produce acid rain, yes. Chemical corrosion, because when you produce acid rain, you can produce carbonate. Carbonate can cause chemical corrosion. Carbon monoxide is known to a toxic of blood. However, thinning the ozone layer is not responsible by these gases, because thinning ozone layer is responsible by CFC. Okay, so the best answer in here is donkey D. 27. Which IUPAC nomenclature corresponds to the structure of alkene is correct? So all the naming is correct. Let's have a look one by one. What are the correct naming? So the first one, what is the correct naming? The first correct naming for A is 3-methyl-pentoene. So A is wrong. Okay, so A is wrong. Okay, as for B, B is 4-methylhextoene, not 4-methylpentoene, which is also wrong. C is 3,4-dimethylpentoene. So this is carbon number 1, carbon number 2, carbon number 3. So it's not 2,3-dimethyl, it's 3,4-dimethyl. So 3 is also wrong. And the last one, 2,3-dimethyl pen-1-ene is correct because this is number 1, 2, 3, 4, 5. So if you look carefully, the methyl is located at the second and the third carbon, therefore making D as our correct naming. Number 28, which compound react with chlorine following the mechanism of a free radical substitution reaction? So which one can react via free radical substitution? Definitely alkane can. Anything that have a saturated hydrocarbon. So including alkane. Wait. Which compound of chlorine mechanism for free radical substitution and electrophilic addition? So if you want to have a free radical, you must have a saturated. This usually occur for a saturated hydrocarbon. And electrophilic addition is usually going to C double bond C. Okay, so in benzene, aromatic compound cannot undergo electrophilic addition reaction, which is not true. So D is already up from our choice. So the best answer in here will be C. Okay. 39. A bromine molecule do not have a dipole moment such as hydrogen bromide molecule, but shows the same type of reaction when react with ethene. So why is it so? It is because number one, bromine molecule has a lone pair electron. So in here, bromine molecule has a lone pair it loves to undergo electrophilic addition because it forms an induced dipole, and hence the partial positive charge act as an electrophile and attack the C double bond C. So the best answer that best explain this statement is C. Okay. Number 30, an alkene reacts with bromine in tetrachloromethane to produce a product with 2 chiral carbon atom center. So which one could be the alkene? Which could be the alkene? So you have to understand what are the product of the reaction after all A, B, C, D's are reacted. So when A react propene after react with bromine, so is there any chiral carbon atom in here? So if you look carefully, there are no chiral carbon atoms. So A is wrong. And then B, 1-butene. 1-butene, is there any chiral carbon atom? So here is the chiral carbon atom. So B is correct. C, is there any chiral carbon atom? Unfortunately, there are no chiral carbon atom. And then for D, is there any chiral carbon atom in here? So you have this one is a chiral carbon atom and 2 chiral carbon atoms in here. Okay, so B only have 1. Sorry, the questions 1, 2 chirality. Okay, so the best answer in here is donkey D. Okay, so with that, I believe that is all for how you are going to answer for objective questions for this one. And I'm going to end my YouTube session for today. So in our next lesson, we shall discuss the structure of the organic chemistry. Okay, so I guess I'll see you all in our next lesson. Okay, see you. Bye.